Hi, everybody, and thanks for attending today's webinar, Codified and Consistent Windows Application Delivery Automation, a simpler way to deploy and update Windows apps. My name is Erin, and I'm on the marketing team here at Chef. I am happy to introduce today's speakers on this webinar as Trevor Hess, Senior Product Manager, and Matt Wrock, Principal Software Developer here at Chef. Before I turn it over to these two, I have a couple housekeeping items to cover. If you have any questions, you can submit them in the Q&A section at any time, and they will be answered at the end of the presentation, unless one of these guys want to address a pertinent question during the presentation. For the best viewing experience, we recommend closing any additional programs or browser sessions running in the background, as webinars are bandwidth intensive. And finally, as always, this webinar is being recorded, and an on-demand version of the presentation will be available by tomorrow. So for those of you just joining, welcome to today's presentation, Codified and Consistent Windows Application Delivery Automation, a simpler way to deploy and update Windows apps. Let's go ahead and get started. Trevor, over to you.
Thank you. Hi, everybody. I'm Trevor Hess, Senior Product Manager here at Chef on the Habitat project. And we're going to be talking today about, as Erin pointed out, the codified and consistent delivery of applications for Windows using Habitat. So as many of us know, we've got complicated Windows deployments, complicated application setups, different commercial off-the-shelf software or COTS applications that we've got to manage and deploy across our Windows server fleet. And we're going to talk today about how we can make that experience better across our organizations by making things consistent, codified, repeatable, and testable. So just quickly going through the agenda today, we're going to be going through a little bit of our perspective on the subject, who we are, why we know what we're talking about, how we solve application packaging and deployment. Then we're going to take it to Matt, who is going to give us an awesome demo of how you can actually see this packaging and deployment mechanism operated. And then we'll share some resources that you can use to get started if you want to try this out afterward. And we'll end with a brief Q&A. So when it comes to Windows applications, delivery is hard. We've got, in most cases, in most enterprises, we've got multiple versions of Windows running multiple languages, running multiple software versions. And you have to remember when deploying those applications across teams, all of those different little nuances and caveats to managing on each of those operating systems with each of those technical difficulties. And that all contributes toward technical debt as we run into new opportunities that we have to pursue while old applications continue to live on because they're still providing value, but there's just not further investment going into those areas, which leads us often to the opportunity to expose ourselves to security risks if we're not keeping that software consistently up to date because teams either no longer exist for those projects or products, or because we need to continue to maintain the patching on those Windows systems. One of the things that we often talk about when approaching specifically the land of .NET is the old adage, DLL hell. So if you want to bump one forward there, Matt, we get a good view of an example of the chaos that can be the map of dependencies when we look at DLLs. And as application developers with .NET specifically, we often find ourselves with these long-lived development machines that have n number of versions of the same DLL installed. And when you try to build a different piece of software for the first time or the 40th time, sometimes you find that those dependencies aren't mapped as explicitly as you need them to be, and you're spending hours trying to figure out which DLL you actually need. So there has to be a better way to manage our dependencies. But if we look from a more broad perspective at the way that our applications look and the disparate nature of things, if you want to go forward one there, custom developed Windows applications often have a very widespread of those dependencies and versions. You may have old applications running from 2003 that are still delivering core business value that your customers still expect you to deliver, but it doesn't quite justify the cost of rebuilding at this time because it still works and it's still delivering that consistent recognized value to your business. But at the same time, on the complete opposite side of the spectrum, you've got modern .NET applications that you're running on modern operating systems that are deployed in a completely different way. And your operators have to understand how to manage and deploy that whole gamut. And today, most teams are still doing this with disparate patterns to deploy and maintain that, which means your teams have to remember and understand how to do all of that, often by hand or with some light automation. And trying to keep that all in mind gets costly very quickly. If we go forward. So who are we? Why do we have an opinion here? Why are we telling you we've got something to show you to help solve some of these problems? Well, we're Chef. We came onto the world in 2008 with our Chef Infra product, which was one of the pioneering technologies in the DevOps space and infrastructure automation as a whole. And over that time, we built and improved that, added some of the earliest Windows support in the configuration management space, working closely with Microsoft. We would go on to add our automate and inspect capabilities so that you get better visualization on those capabilities. And then we introduced Habitat, which is our vision on how application deployment and delivery should look going forward so that we don't have all of these ongoing struggles and disparate ways of representing our different applications that need to be deployed. And if you bring that forward, we talk about our whole enterprise automation stack, where you can thread all of those pieces together to have a beautifully defined way of maintaining your entire fleet of infrastructure and applications. And then this year, we also launched our desktop and compliance offerings, but that is a story for another day. So talking a little bit more about our broad capabilities, as I said, we've been doing Windows and general Microsoft capabilities for as long as I've been at Chef. Matt and I have worked on different Windows components across the Chef ecosystem for the last 4 or 5 years, bringing in some of the abilities that we have today, like desktop management, the ability to manage Edge and Windows embedded systems, the ability to maintain policy and security compliance for your fleet by enabling configuration management, patch management, and adding the ability to deeply audit and remediate policies that you defined for your systems and applications. Bringing us to the world of application delivery, which is what we're here to talk about today, where we deliver the capabilities in application packaging, deployment, with the ability to drive automated rollback with deep integrations into CI/CD tools like Azure DevOps, and give you the ability to accelerate your cloud migrations by packaging applications in a way that they can be deployed anywhere. Application delivery lets you define and package your automation with software that can be shared, tested, trusted, and actionable. Go forward one, Matt. So what does this look like? The first thing that we do is allow you to define your application. So we let you to write the rules about how your application is built, deployed, and maintained. All of the steps as part of your application that takes it from concept to production. We give you the path to define that in code that can be shared across your team, so that at the end of that, you wind up with a package. If you want to give me a little advance there, Matt, thank you, that you can then take and run anywhere. You can even connect that into your next piece, which is the CI/CD system. So you can simplify the use of your existing CI/CD tools rather than having to set up an individual deployment for every target that you want to have, be it a different operating system or a different location for an environment that needs to be shipped to, whether that's literally the actual system it's running on, container or VM, or if it's the environment that you define, such as dev, test, or production, you can simplify your pipeline by having it produce a single package that can be deployed and configured on any of those environments. And we've actually got some great customer stories that have gone out and done this already. If we go forward once more, we've got folks out there like Panera Bread. Panera has actually rolled out Habitat to their stores, and they've been able to take their deployment lifecycle for their Windows applications to those locations from months to days. So that is a huge savings. And they're also able to deliver that same capability to their dev and QA environments. They've now got 99% availability on their dev and QA environments. So their teams have on-demand access to test and validate any of the pieces that they need to. Another huge story comes from a Fortune 500 auto manufacturer. They've reduced the amount of works that their teams have had to do on nights and weekends in their DevOps space 90%. There's 90% less hours that these teams are out there doing the soul crushing work of getting things done outside of hours, which is just is wonderful. And you can see here some of the other stories that our customers have been able to tell. Another great one is Alaska Airlines has been able to do applications with no application deployments with no disruption to their business from that application deployment in a way that they were previously not able to deliver. If we go forward, what does this look like? So when you've put an application into the world of Habitat, you're going to create an application manifest, which is going to be a single declarative application directory that lets you provide consistent and clear definitions for the different stages of your application going from being constructed to being in production and operating. So you're going to package up your code base, the instructions you need to build your software, the instructions you need to configure your software, the relationships it has with other elements of your software. So like, for example, a database connection or a logging connection. The dependencies your application relies on to actually operate. So this could be those DLLs that you need to have packaged alongside your application for it to operate correctly, as well as the runtime instructions. How is it that I, as an application, operate on a given system? What steps need to be taken so that I can go from being deployed as a package to running and being operational and providing value? We go forward one here. We can look at this a little bit more broadly as well. If we take a look, we've got every step that you need to take to get from a piece of code all the way out to a tested, reliable piece of software running in your production environments. So you could start all the way back at the Habitat Studio, which provides a clean room environment for your developers to build and test the applications that they're working on without worrying about that long-lived development environment we talked about earlier. And all of these tools are built using simple familiar languages like Bash and PowerShell that the teams are likely already familiar with from other opportunities that they've had in their experience. When you get your package built, you can throw it into a tool we provide called Habitat Builder, which is your package repository for your applications in Habitat. And that's going to provide you with APIs to manage and audit the different capabilities of your software in a way that you can ensure chain of custody for your application versions and deployments and maintain compliance, knowing what software is deployed where with what versions of its dependencies. You then get into the actual package itself, which we call the Habitat artifact, which is represented by a heart file, which is a single signed, compressed, versioned artifact that includes the things that are defined as part of your application's manifest. When we get to deployment, we give you the ability to be flexible with the environments that you're going to be deploying to by creating what we call channels. So you can have, a channel can be anything that you need it to be, but what we see most commonly used is defining things like a development QA, test, and production environments, or pre-production, whatever your flow of pre-production environments looks like. You can create promotable areas that you can use to test software and manage updates so that your software is being updated in a way that is rolled out smoothly. The supervisor is what we use to manage those runtime capabilities that we talked about. So we use patented technology to manage the stages of your application that it needs to operate. And Matt's going to go into some detail on what those stages look like and talk a little bit about lifecycle hooks in his portion, in his demo. So I'm not going to spoil much there. But you get to actually take all of this data that's generated from these previous steps, and you can view it in our Chef Automate tool. So you can see real-time visibility and ongoing analysis of how your applications are operating. So if something happens to go out of policy, or if you notice something that needs to be changed about your application, you can see what versions are deployed and things of that nature so that you can update the code as part of the application definition to remediate it, build a new package, publish it through to Builder, and roll that update out through your channels. Which gives you the ability to pipeline your compliance and make sure that your environments are hardened. And Matt is absolutely right. That means it's time to actually see what this looks like rather than listen to me talk about it. Let's actually show you what this does. Matt?
All right, thanks a lot, Trevor. Yeah, so what we're going to do today is, or what I want to do in this demo is basically show you how you can use Habitat to automate your application. We're going to be using an IIS-based ASP.NET full framework application. And really what I want to get across here is kind of the life cycle of what Trevor just talked about in terms of putting together these different Habitat artifacts and seeing how these different Habitat pieces work together. So the very first thing that we need to do in that process is to deconstruct our application. So what is our application going to need what do we need to build the application, and what do we need to run the application, and how do we tell that to Habitat so that all that stuff is set up for us at the right time? So to do that, we're going to be creating a Habitat plan. And here you can kind of see the skeleton framework of what that looks like. In this image, we've got plan.sh. If I was writing a Linux-based plan, that's absolutely what it would be called. We're going to be, because this is a Windows.NET application, and we're focusing on Windows in this webinar, it's going to be a plan.ps1 file, so it's going to be PowerShell. We're going to have a hooks directory in here, so we'll look at a couple hooks, see how that interacts with the Habitat runtime and informs Habitat as, while your application is running, specific operations to perform during particular points of your application's runtime. How Habitat interacts with your configuration. So we'll be looking at default.toml, how we can, and configuration, how we can inject at different in different runtime environments, different information, and how we can kind of tune that. And we'll be looking at how we code that into our plan. So we'll be looking at all that, and then when we're done with that, when we have all that put together, we're going to actually build that plan. So we're going to produce that heart file that Trevor mentioned, that single signed artifact that's going to contain all of our binaries, all of the code that needs to run our website, our CSS, our JavaScript. It's going to have our hooks that's going to talk to the Habitat supervisor. And just to be clear again, the Habitat supervisor, I'm going to use that word a few times. So that is that runtime piece, that small little runtime agent. On Windows, it runs as a Windows service that's basically watching the services that it's running, which would include our application, and can execute code that we give to it to perform during different parts of the lifetime. We'll get into that a little bit more deeply, but we'll be doing that building and running inside of a Habitat studio. So Trevor mentioned that, and so we'll actually see what that looks like, and we'll talk a little bit the benefits of that environment. Real quick, I want to touch on a few things before we dive into the demo. So there's some things that we're not going to really have time to go into detail, but you can kind of consider these maybe good topics to delve into, or you're totally free to ask us in the Q&A as well. You know, at runtime, there's lots of neat, you know, kind of more advanced things that Habitat can do, like rolling back, like performing updates. So I can produce new packages. I can upload those to the Habitat Builder service that Trevor mentioned. And I can have my supervisor on my application servers watching for new updates. And when it sees those, it can pull those down and it can update my application. And it can also, if I tell it to, roll back that application to a previous version. We've got things like cluster awareness. So if you have an application, like let's say Postgres, for example, that has a leader follower type of a pattern, we have mechanisms that support that. We support things like health checking. So if I want to see if my application is in a healthy state, I want to get some kind of reporting back on that. That's something that we support as well. We're not going to go into detail on those things, but I want you to be aware that those are all things that we absolutely support. And later in this talk, we're going to show you some resources and where you can get more information. And there's, you know, volumes of documentation and blogs that we provide for you that talk on these different things. Now on the right here, I am going to go into more detail on hooks. So I've talked about hooks a little bit. Hooks are basically bits of code. In our case, they're bits of PowerShell that talk to the supervisor and tell the supervisor what to do at various points of our application lifecycle. So I'll give you some examples of that. Let's say we stop our application and there's some bit of script that we would need to run that has to be performed after the application stops. So we'd have a post-stop hook for that. And almost all these hooks, except for the run hook, are optional. So, you know, when the supervisor gets to these various points of the life cycle, if the hook's not there, it's just not going to run it. Or sometimes there's some default behavior. Post run is a good example. So take SQL Server as a good example of this. If I have SQL Server as a Habitat package, and we have an example where we do that, and there's a lot of configuration for SQL Server that can't be performed until the SQL Server service is actually up and running. And so there I might use a post-run hook to do that configuration. What the hook that we're going to be looking at in detail here is the run hook, and that's what tells Habitat how to run the application. So it's important to know that Habitat is totally runtime agnostic. It doesn't know anything about .NET, doesn't know anything about Ruby, Go, your crazy COTS application. You can absolutely package all those applications, but you as the application developer or application operator, you know things about the application. You know how to start the application. And so these hooks are your opportunity, and the run hook is your opportunity to tell the Habitat basically how to make the application go. So, so with that, let's dive in and get into the nitty gritty so you can actually kind of get a nuts and bolts feel for how all this works. So, so this, what we're looking at here, well, first of all, what we're looking at here is Visual Studio Code. So this is my code editor. You might have your favorite code editor. And over here on the left are, you know, basically this is my source code. So I've got, I'll compress that folder, but you know, I've got my controller, so I've got some C# here. I got some routing here. So this is all my source code. And in fact, what this application is, so if you were to open up Visual Studio and you were to go to File, New Project and open up a fresh ASP.NET sample application, this is exactly what you get. So I in fact did that, and I copied that code over here. And I do that to illustrate that I can take some other application, like this application wasn't specially designed for Habitat, or I didn't have to go in here and like muck with it to make it work with Habitat. I just took this application as is. It's a pretty simple application. You know, it's just a kind of the vanilla sample ASP.NET application, but nothing's been changed to it. What I did add was this folder here. So this is my Habitat folder, and this kind of corresponds to that image that we looked at in the slide before. And this has got my hooks. So I've got a few hooks that I've got my run hook, of course. I've got an init hook. I've got an install hook. I've got some default TOML. We'll get into all this stuff. What I want to look at now is the plan. So the plan is the basic building block that tells Habitat how to package my application. And it's basically made up of kind of two things. I like to think of it as separated into two sections. The first section, this section's like lines 1 through 17 here, basically are defining metadata about my application. And then the second section is giving me the opportunity to tell Habitat how to build it. Again, Habitat is runtime agnostic. It doesn't know, like Habitat out of the box has no idea how to build a .NET application. But this is where, but we do, right? Because this is our application. And so this is our opportunity to tell Habitat how to do that. So let's just kind of walk through this a little bit. Some main things I want to touch on is, first of all, the dependencies. So Habitat allows us to delineate dependencies into build time dependencies and runtime dependencies. So my package depths are my runtime dependencies, build depths clearly my build time dependencies. So it's an ASP.NET full framework application. What am I going to need at runtime? Well, I'm absolutely going to need the .NET runtime, right? Now, most modern Windows operating systems come with the .NET runtime already installed, but I might need a particular version. So I'm building this against the 4.7.2 runtime. So I need to make sure that either that or higher is installed. So I'm going to take a dependency on this package. So all of these are packages themselves, and they have their own plans and their own hooks. So I'm going to need that at runtime. I'm also going to need to make sure that IIS has all the ASP.NET 4 modules and plugins set to go. So I'm going to pull in this package, and really what this package does is this is going to make sure my Windows features, my ASP.NET 4 Windows features are enabled. And the other thing to understand is all of these dependencies you see here, these are my top level dependencies. So clearly these dependencies may have their dependencies. So for example, IIS ASP.NET 4 has a dependency on the web server role package, which is another one that's going to make sure that IIS is at least up and running. So basically the point is that once this is installed and all of its install hooks have run, I have an IIS instance that's set to go and ready to serve up an ASP.NET application. And then lastly, for runtime, we have this DSC-core package. This is a package that we wrote. It's basically a PowerShell module that makes applying DSC configuration simple inside of Habitat. So for those that aren't aware, DSC, that's a PowerShell concept. So PowerShell DSC, that's desired state configuration. It's not Habitat specific at all, but for those who are familiar and like using DSC to configure their systems, Habitat provides a way for you to easily integrate with that. We're going to show you that, and it's actually going to make setting up our IIS primitives pretty straightforward. So at build time, what are we going to need? So that's our runtime dependencies. At build time, well, we need MS build, right? Like C# needs to become a DLL, and we need MS build for that. So we're going to get that with our 2019 Visual Studio build tools. So this is going to pull down all of that. And what's great is that all these build time dependencies, these do not go on our application servers. So this 2019 Visual build tools, it's hundreds of megabytes. Like, we don't want that everywhere. We only want that at build time. And we're also going to pull in NuGet, because NuGet is going to get us our package dependencies. And while we don't need the specific version of the .NET runtime to build the application, we do need that specific version of the reference assemblies to bind to in order to compile our application. And that's what this dev pack gets us. So MS build is going to point to that and use that to compile our application. So that's our dependencies. And when we build this package, the version of the dependencies of this package gets included with this package, basically will move along with this package. So if I install this package somewhere else, the exact versions that I built with will get pulled in as dependencies for that package that I install elsewhere. So real quick, let's talk about some of these callbacks. So there's tons of callbacks that I could use during different parts of the build life cycle. That's stuff that you can read into or ask questions about later. I want to talk about just a couple of these functions that we need to get this basic website up and running. So first, we need to call MS build and NuGet just to build. So I'm going to call the build target of MS build, and that's going to basically produce my DLL. And then lastly, I'm going to call this install method. The invoke install method is what Habitat calls to actually package the application. And so I'm going to use MS Build's web publish target. So this is basically does the same thing. Like if you're a Visual Studio developer and you right click on your project and you say publish, which allows you to send all the artifacts of your application to a folder or maybe to Azure. That's basically what under the hood, it's calling this MS Build target. And this is going to basically assemble all of those files. So it's going to get my built DLL, my CSS, my JavaScript, everything that my application needs to be for IIS to serve up that website. And it's going to plop it into a directory that's going to get included into that final package. So that's all I need to build this package. Before we get into the hooks and configuration, and while this is fresh in our minds, let's go ahead and build it. So I am going to switch on over to my console. And so what I'm in here is a Habitat Studio. So Trevor mentioned this before, and we have a couple flavors of Habitat Studio. We have a Docker flavor and a non-Docker flavor. And one thing I just want to make clear right here, if you, for whatever reason, can't run Docker in your environment, that's fine. But I'm going to go ahead and use a Docker Studio. So I'm in a Docker Studio. So I'm actually in a Docker container right here. And doing that gives me a couple of nice benefits. One benefit is that it is crystal clean. So I have all that's in this container is just a vanilla Windows Server Core 2019 operating system, the Habitat build system, and the Habitat supervisor. So the benefit that gives me is, like, let's say I didn't have this and I was on my laptop and I built it and I tested my website and I've got like, IIS plugins. I've got the redirect module that my application needs, plugged into IIS. I've got some COM, too bad for me, but I've got some COM registries that my application needs to run, on my machine, and everything works beautifully. I'm so happy, and I move it to production, and it all fails because it doesn't have those things. So the idea is that here, if I didn't define it in my plan, it's not going to get it here. It's not going to have it here. And so when I test my application, it's going to fail, which is a good thing because I'm in the studio. This is an iterative process. So I'm testing the build, I'm running it, it's failing, I'm folding in whatever additional pieces I think my application needs to run until the end I have a working application. And so then the idea is I have this package that I could send to any other environment that has nothing and my application will run. So let's go ahead and build it. So in this studio environment, I have a command called build available to me. And then I'm going to give it the directory where my application lives. And I'm going to run that. So now this is the Habitat build system. So the first thing it's doing is it's just doing some dependency resolution. So all those dependencies that we saw in the plan, it's checking to see, are they on disk? If they're not on disk, it's pulling them down from the Habitat builder service that we talked about. And now it's actually building. So there, NuGet is doing its thing. It's pulling in its packages. Now MS Build is running. So MS Build is actually compiling the C# here, and it's going to do a DLL. And now we're in the installing phase. So it's calling our invoke install method. MS Build is doing the web publish target. And now that's done. Habitat is now generating that final heart file. So in just a couple seconds, I'm going to have a heart file that I could upload to the Habitat Builder service. I could, copy it over to some other system. I'm here in the studio, and when you build it in the studio, it actually installs it here. So we're going to actually run it in this environment. Because the other thing that you have here is you have a supervisor running in the background inside of this studio environment. So I could type hab SCC status and just talk to the supervisor and say, hey, what's going on? And it basically says, nothing. I have no services loaded. So we're going to load a service. We would say hab SCC load mrock / hab -sln. And if I hit enter, what would happen, and I'm going to do that in a bit, but it would load this up and run it. So first of all, what's this mrock / hab -sln? Didn't really talk a lot about that. So Wrock is my origin. You can kind of think of that as a point of ownership, or it's synonymous with like a GitHub organization. If this is a real package for a real company, it might be the company's name. So for example, packages that Chef officially produces would be under our Chef origin. And then that second part, the hab-sln, that's just whatever I give it as the package name inside of here. And so when I load that application, which we're going to do in a bit, what's going to happen? It's going to run the application. So that's when these hooks come into play. So let's actually take a look at our run hook, because this is the most important one. This is what tells Habitat like how to start the application. And all sorts of different runtimes have different ways of starting. You know, if this were Node, I'd call the Node executable, point it to my application, and it would just run. But like, how do you start an ASP.NET application? Like, there's no command necessarily that you like. I guess that you could type a PowerShell command to like start your IIS website, but basically it's all IIS, right? So what I'm going to do first, this is probably the most important line in this whole hook, is the start-DSC core. So this is a function that gets exported by the PowerShell module that that we pulled in here, this DSC-core dependency. So that's going to be available. That's by pulling that in as a dependency that's in our PS modules path. So that's available to use its functions. And basically, what this function is going to do, it's going to apply the DSC configuration that exists inside of this file, this website.ps1. So that is actually inside of this configuration directory. So let's look at that. So for those that are familiar with DSC, this might look familiar to you. This is just a straight up DSC configuration. Again, it's not Habitat specific. This is all DSC syntax. It's basically making sure that different IIS-based primitives are set up the way that we want them to. So this is going to set up our application pool, our website, our web application. And what is Habitat specific here is these handlebars, or excuse me, these double curly braces. We call that handlebars syntax. It's basically our Habitat templating. It's the thing. It's the mechanism by which we can inject configuration information that varies from environment to environment at runtime. So PowerShell wouldn't know what to do with these double curly braces. But before PowerShell and DSC ever gets this, Habitat will inject and replace these with actual values. And so what you want to think about when you're developing your package, you know, either as a developer or as an operator, you know, this might be a conversation that a developer has with their operator is, what are the tunable pieces that need to change from environment to environment? A good example is this one down here, port. So I might want my application to run on a specific port at development time, like in my development environment, but it's going to need to run on a totally different port, like maybe port 80 in a production environment, or in a different test environment, might be a different port. And Habitat provides all sorts of different ways by which we can inform that environment what the values of these particular variables are, port or app pool, are at runtime. But if I don't tell it anything, what it's going to do, it's going to use the values that are in this default.toml file. So this gets packaged up with my heart file, and if I don't tell it anything, and I'm not going to tell it anything in this demo in the studio, it's going to use these values. So it's going to use, for example, port 8099 to run. And so let's go ahead and just enter this. So I loaded it. It basically just very kind of quickly tells me, okay, I loaded it, but clearly that run hook is doing stuff, and I'd like to see its output. So the studio gives us this command called get supervisor log, and I'm going to see what's happening here. So I can see it's compiling the DSC MOF. That's just kind of a DSC-ism. So when you create a DSC configuration, you have to compile it first. After it gets compiled, you then apply it, which means it's actually interacting with whatever's it's being told to configure, in this case, IIS. So it's doing that right now. It's applying the DSC configuration. And so basically the idea is like once this applying is done, so once all, you know, my app website, my app pool, if you're familiar with IIS, you would know that you can hit my app. Like my app should be accessible and should be up and running. And what we've done in our run hook is we've output this little information. I'll show you how we did that. So basically we just do a, we've got this right host, and again, here's we've got our little double curly braces. Here's our app name, and our port. The IP is off the sys namespace. So all this stuff off the CFG namespace is in our defaults TOML file. The sys namespace, Habitat knows about. Habitat knows what our IP address is. And so I get this URL. So let me copy this. And I'm going to go back to my browser. Let me get out of this presentation mode, bring up a new tab, drop this in. And here we go. So so this is my running application. This is the IP address of my container, and this is, Habitat built this. It's running it, and I hope this is helpful. I hope this is somewhat clear, at least. How you would get from source code to running application in Habitat. So with that, I'm going to hand it back on over to Trevor.
Thanks, Matt. Thanks for doing that demo. That was awesome.
My pleasure.
I want to bring us up to, there we go. So if we kind of look through what Matt just showed us, we just saw that we've got a way to represent our applications running on Windows operating systems in a clear, shareable, testable, trusted, and actionable definition. And that's done in Windows using PowerShell, which is a tool most Windows developers and operators should both be familiar with. You're going beyond basic packaging capabilities, so you're able to explicitly map those dependencies that you have clearly defined packages that contain the things that are needed with faster builds using a single origin and including all of our build and runtime instructions. And once you've got that package, it can be run anywhere. It doesn't matter which version of Windows it is, 2012 plus, or it doesn't matter if it's a container or a VM, and it doesn't matter which cloud you're trying to put it onto. You can go put that package where it needs to operate. And finally, you can simplify that change management and scale across all your Windows apps. And this pattern also works for Linux applications as well, using Bash instead of PowerShell. So if you're interested in poking around with this and learning more about how to use Habitat on Windows, you can visit our new Windows Resource Center. So if you go to community.chef.io/windows-resources, you can actually walk through the demo that Matt just showed you yourself and build an ASP.NET IIS application from scratch and see that deployed in a Habitat package, and try some of our other samples and demos as well. And with that, that is our presentation for today. So again, Chef App Delivery is going to be the thing that lets you define and package your automation for your software that is shareable, testable, trusted, and actionable. And now we're ready to take some questions. If you click on the Q&A button in oh, sorry, Zoom just popped behind on me and I thought everything ended. Sorry, if you have any questions, if you click on the little Q&A button at the bottom of your Zoom webinar window and go ahead and type in any questions that you might have, we would be more than happy to answer those. While we wait for some of those to come in, Matt, we talked earlier a little bit about being able to manage rollbacks with Habitat. Can you tell me a little bit more about how that works?
Yeah, so basically that's a somewhat new feature in Habitat, and so typically, like, you want to roll forward, right? So that's been in Habitat forever. And what you do is you promote your application. We didn't really look at the nuts and bolts of that, but there's a command where you promote it. Your supervisor is watching a particular channel, so you promote to that channel, and it updates it to that version. But then let's say, oops, I think a lot of us have been in this situation where things don't always go as planned. So we want to we want to roll back. Now, of course, one strategy is to just keep rolling forward. But Habitat does provide you the means. There's a special command that you can give to the Habitat supervisor, where it will go back to a specific version and load and run the previous version of your application. So of course, your application has to be rollback friendly. So this can get very sticky when you've got database applications and you've got different versions of the database and versions of the application. So there's ways that you can coordinate all that. But I want to make so that's that in a nutshell. That's how that works. So it looks like we've got a question here. Is there a Linux? This for building RPM.
The question is there a Linux, and they're asking specifically RHEL 7 or 8 version of this, so that you can build specifically RPMs or a webinar on that topic. Matt, do you want to take this as well, or?
Sure. Yeah, I'll take it. So typically, what you build with Habitat is a heart file, and there's all sorts of actually interesting things on Linux that we obviously didn't get into here that have concern. Like, there's a reason why you would want, like, I understand with the asker why you would want one specifically geared for a version of Linux. Now with Habitat, you don't build RPMs or D packages or any of those different flavors. You build heart files. But the way that Habitat packages are built, and we didn't get into the nitty-gritty of Linux-based packages, but the way those packages are built is they're built to be distribution agnostic. So basically, I can run my heart file, and it should be able to run on Ubuntu, SUSE, Red Hat, and we have different. We also have a different SKU for Linux, for Linux kernel 2 as well. But the way that the way that you would author a Habitat package on Linux, you can and set up your dependencies. It's a little bit different from a lot of the Windows patterns you see, where you take dependencies all the way back to like glibc, and so if you have a certain set of libraries that are available on your distro, it doesn't matter. You define basically all that whole set of dependencies in your Linux package. So you've got your glibc, OpenSSL, whatever. And the way that it builds the package, the dynamic and the dynamic linking will be set up in such a way that will only pull the DLL, those Habitat-based DLLs. So that's actually a super nice feature. That's fairly Linux specific. Windows has kind of the way that it's library dependencies works much differently than Linux. We could do a whole separate webinar on that topic alone.
Speaking of other webinars, we definitely do have other webinars that we've run in the past, specifically discussing what it looks like to run a package on Linux from Habitat. So I'll see if we can get that added to our follow-up email that'll come out after the webinar, so that you can get some specific insight into that. But you can also check out the community page for Habitat, and you'll find some links to some videos and demos there as well. Matt, another question that's come in is, what's the difference between Builder and something like an Artifactory or Nexus?
Yeah, that's a great question. So first of all, there's definitely similarities. So I guess the difference is that Builder, well, there's several differences. One of the main differences is that Builder is specifically a repository for heart files. So whereas Artifactory or Nexus, will work with Ruby gems and all sorts of different types of files, Builder is specifically for heart files. The other thing is that Builder, at least our public Builder service, it's much more than a repository. So it is a repository. It is a place where you could upload your built files. But here's what's great, is it can actually do the building too. So you can basically bind Builder with a GitHub repository, and it can see that changes have been made to that repository, and it has, it's kind of like it's got its own basically CI built in. So we have workers in our own cloud environment, both Windows workers and Linux-based workers that will build your plans. So let's say if you don't have a studio, if you just change some source code, commit it to your master or main branch, the builder service will pick that up. It'll actually rebuild it. You can get the log, so if it's got failures, it'll show you that. If it's successful, it'll go ahead and publish it and add it to your repository where you can promote it to whatever channel you want to.
Yeah, that's definitely one of my favorite features of Builder, and that is the build capabilities specifically are something that are exclusive to our cloud platform version of Builder. So that's something that you can get by working with us on that cloud, the Builder cloud platform. Matt, another question: how does Habitat represent or see transitive dependencies? So if you've got a package that depends on another package that depends on other packages, how can you get insight into that?
Well, that's a great question. So I briefly touched on this, like in that ASP.NET 4. So it has a dependency on the web server role package, and then like that the Visual Studio build tools, that's got some dependencies as well. But let's say, I think what you're getting at is, I've got this big old dependency tree. How do I actually see the whole? How might I see the whole tree? So in my plan, I just see my top level dependencies. But clearly, it can go much deeper with that. In fact, actually, we can actually go and take a look. So I could cat out. Let's see. So there's when Habitat builds just copy this. When Habitat builds the package, it builds out there's a bunch of metadata that gets produced. And so for example, build depths, I can see, okay, those are my top. Oh, here, I know what it is. T depths. So, okay, yeah, so actually it's only, I just get one, so I hit this web server role. So in some cases, I might have, like let's say it might be a native app, and there might be something underneath that takes a dependency. So on Windows, it might take a dependency on the redistributable C++ library, or it might be an old legacy app that takes a dependency on a COM package, all the way down. On Linux packages, this might be very tall because, like I said, we'll go as far, oftentimes you'll define your dependencies all the way down to glibc. Windows is a little bit different because basically on Windows, you have all of those low-level libraries like kernel and all the the low-level stuff that gives you all that user and process definition. That's kind of baked into the Windows operating system, so you just kind of get that. But at any rate, the short answer is you get this T depth, so transitory dependencies. So this is going to show you your whole tree. And what this means is that when I deploy this to another system, these exact versions are the versions it's going to pull in for its dependency. So if there's some other version, it won't pull in that other version. It's only going to pull in the versions that I actually built and tested this with. So
that's excellent. Yeah. All right. I think that's all of our questions for now. We'll kick it back to Aaron.
All right, great. Thanks, guys. We will close it out there. Just a reminder that the on-demand version of this presentation will be available by tomorrow, and we'll email you as soon as it's ready, and you'll be able to access it using the same link that you're using now. And yeah, with that, we will close it out. Thanks again, everybody, for attending. And thank you, Matt and Trevor. And have a wonderful rest of your day.
Thank you.